So today we're going to talk about this State of AI report. This guy Nathan's been producing it for a number of years, and there's quite a few slides. So I don't think we're going to go through all of them. We may not want to just depending. We'll see how fast it goes. But so this is the opening page, and he's got a few summary bullets, key takeaways here. So I figured we can kind of look at these, and then I'm sure they will reappear on various slides, but there'll also be more other things on the different slides. Um, so number one, right? GPT-4 is still the king. Um, I think that's pretty much widespread agreement. Nobody's thrown the compute. Nobody's figured out a way to dethrone GPT-4 yet. Although obviously people are working on smaller models, but the smaller models are usually like see how close we can get to GPT-4, not to actually lap it. Anybody have any comments on this
Yeah, so
takeaway?
there's a new one called Zephyr. I don't know how to pronounce that exactly, but Zephyr, Zephyr. That just got announced like a week or two ago, and apparently that has been doing pretty good in terms of performance, including beating GPT-4, and it's a 7 billion parameters model. So worth looking at. I have not looked at it as of now, and definitely not looked at it in details. Um, Also, there's another one called Mistral from France.
Mm-hmm.
It's in the news all over.
Yeah.
So there are these two, but in terms of beating GPT-4 performance, uh, the spider chart that was published for uh, Zephyr 7 billion beat uh, beat GPT-4, it seems, in almost everything.
That
That's
seems
impressive.
hard to imagine. I mean, I could see beating it, but for only a 7 billion, not
Yeah,
even
that
like a
was
50 or 70.
Yeah,
yeah,
it was.
that well, both of these are 7 billion because your Zephyr, right, is the 7B too, right?
Yeah, even and Mistral is also 7 billion. Yeah.
Yeah. Mistral's 7 billion too, right? So they're both.
I'll put the Hugging Face link as well for Zephyr, and let me see if I can find the. Uh, so it is okay. So here's the deal. Zephyr has been fine tuned from Mistral 7 billion, it seems. So I'm looking.
Oh.
Let me post the Hugging Face link as well.
Hmm.
In this area, has anybody really looked at kind of what's the quantitative, if we can, qualitative, if not, difference between like GPT-4 versus GPT 3.5?
So
Yeah.
quality depends on the domain, of course, right? So someone has to qualify for what kind of use case, task, and domain we're talking about. So when it comes to coding, Python coding, C++ coding, or some other coding, or is it summarizing, or is it following some other instructions, right? So typically for coding, like Llama ended up releasing a separate model, Code Llama. For that matter, even GPT-4 has a plugin. As such, GPT 3.5 and 4 do work out of the box with the instructions, but they have separate plugins which are supposed to perform better than the default GPT-4, for example, right? So if you are a plus user of ChatGPT, then you can subscribe, then you get access to those and it does better. My experience in various tasks, and much of my tasks are related to mathematical reasoning, code, blocks generation, and uh, sometimes content generation, or kind of messages, if you may, right? So uh, GPT-4 is way better than any of those. I have not downloaded Mistral or Zephyr. Um, I did have Llama, uh, and I did fine tune Llama 2 for one of the tasks, which it did fine actually. With 3 epochs itself, it did really good. Um, so, but that was like fine tuned for a specific task. But out of the box also did fine with summarizing, but they had to, if you know, right, they have this code Llama, a separate stream of a separate product for coding, for example, for the code help. So it depends. That's my take on it. I don't know what others think or their experience.
Yeah, I mean, it seems to me mathematical reasoning, any kind of like analytical thinking, and then I don't know how to say it, but just sort of like the finer touch on tone and voice. So whether it's summarizing or generation, like if you kind of want that slightly more sophisticated, or like if you're trying to imitate a particular well-known person's tone, it seems to me that's where the common tasks that GPT-4 seems to still be the king. I don't know about translation. I haven't played or read about translation much.
Translations. Like recently, I asked it to generate a poem in Hindi. Gave it uh, gave it instructions on what I wanted, like uh, funny and whatever, right? How many lines and rhyming or not rhyming, and this is the gist that I want in like 4 or 5 points. GPT-4 was better than GPT 3.5. Sometimes even GPT, like this is reported by others as well. Sometimes it wouldn't follow the instructions, like it will forget the instructions as if, it didn't pay attention to some part of the instructions. More so with 3.5, very, very less with 4. But not directly translation. I think translation is also, I'm not too impressed with the translation, um, but I have not tried a lot either, is what I'd say.
Well, I actually, when I use other language model in Spanish, because I try to use it in Spanish, they are pretty bad or not working like Llama or these small models. Even Cloud and Bard sometimes are really have better performance on English. But when I try ChatGPT with GPT-4 or GPT 3.5, it's like talking with something that knows the language. It's not translating. It's just like knows every word. And one time I made some kind of a test when I speak between languages understandably, and it also knows every meanings, like it understands it. It just don't translate it. It understand the language. Something that other large language model like Cloud or Bard try to like translate it before giving a result. So it comes, the output is not as great as it will be in English.
Yeah, and I have to say, I use, like a lot of times I would even have the same task spawned out to all 4, right? GPT 3.5, 4, Cloud, and Bard. Cloud is the next best amongst all of these, and that can be seen even with the ELO rating. So there are some websites that have ELO rating for these models, and definitely, Cloud does fine, but again, hands down, GPT-4 does excellent. GPT-4 makes mistakes, by the way, especially in mathematical reasoning and coding side, but less compared to others, way less. It also, like once I gave it an algorithm, which was a dynamic programming algorithm, but unfortunately, it was not using all aspects of dynamic programming, so there was some subtlety, and I knew that the complexity was exponential. I asked it to tell me what's the complexity, and of course, none of the tools did fine, but GPT-4 also said it's order m or m square, something like that, whereas it was exponential. So you have to be very careful.
Yeah.
When you do that,
the impression that I had is it looked like a lot of the open source models were trying to compete against GPT, but it was GPT 3.5. Kind of, can I be on par with GPT 3.5 with a much smaller model? I hadn't noticed where people were doing, okay, what if we scale it up by another factor of 10? Can we then compete with GPT-4? But GPT-4 seemed to be in a different camp.
I think there's a financial thing there. just a resource sort of thing. When you try to scale up beyond 7 billion, it just seems to be exponentially more expensive to move forward in that. So that's why most of the open source seems to be, up to what I forgot. Some of them are running what at 30-ish, 50-ish now, or something like that, but considerably smaller than GPT-4.
So there are companies, and many would not even announce if they're doing it on internal data, right?
Mm-hmm.
But there are definitely startups who have come out and compared the results against GPT-4. I had shared one 6 months ago or 5 months, 3-4 months ago, a company called MoveWorks. They work in IT service management, facilitation, and the workflow management within the enterprise related to IT and hiring and HR and other processes. And they had announced their model MoveLM around 4 months ago, where they compared with GPT-4, and once they fine-tuned a 7 billion model on GPT, I think they used MPT 7 billion at that time. They beat GPT-4 with the fine-tuning. And now this week, earlier,
Fine tuning it on what problem set?
their own
Their tasks. Okay.
Their data set. So currency
Okay.
is the data set at the end of the day, right?
Yeah. I'm just wondering here, because GPT-4, a lot of these comparisons are like on a broad spectrum of tasks. I could see it getting beat on a lot of on a more focused task.
So to answer Roger's point, right? So maybe for the generic task, people may compare it to 3.5, but more often than not, there is customization that you need to do for your enterprise. And in case of like MoveWorks, when they take it to individual enterprises, they also have to personalize the workflow within a company may be different from another company, right? So not only, well, whether you call it personalize or customize, but what I mean by that is that for each company, they have to customize the outcome, not just for a specific domain, but also for each individual enterprise, they have to have a module sitting on top or fine tuning sitting on top of it. So they do talk about all of those in a recent white paper or article that they published, and I went through that. So there are companies when they have a specific focus of task, right, use case or set of use cases, and they have data set either, and they also, I'll come to that part also. So then they are able to create models that can be applied for their use cases. Of course, we know that OpenAI through Azure or otherwise has APIs, the enterprise for fine tuning, right? The enterprise solutions for fine tuning or interfaces. They came up with that like a couple of months ago, if I'm not mistaken. Someone correct me if I'm wrong.
So Dave, I'm sorry, but like for the sake of time, maybe we want to like keep moving on and hitting some of these other points instead of spending all our time kind of on this one point.
Yeah, I'm okay with that. Yeah, Roger, you are okay with that? I was just trying to answer your question here.
Yeah, no, I'm good.
Yeah,
I think some of these details will come up as we go through the later slides. So, but just again for the sake of time. So we've kind of already talked about this second point, right? So GPT-4 is king, but what you see in the open source domain is smaller models, and as Dave just said, the main way that you can try to beat performance of GPT-3.5, GPT-4 is with better data. So if you have better chemical data, then on chemistry questions, you can beat GPT-4 generic, right? If you have whatever, better housing data, whatever, that kind of a thing. So definitely you can fine tune, you can do better on one thing, but to try and beat it on everything, so far, I don't think anybody's able to do that. And
I was doing this course recently, and one thing we brought up was Bloomberg GPT, right? So obviously financial data, very, very focused, tuned version for that, very fine tuned. And yeah, it does beat, GPT-4 at that particular game.
Right. Yep. What's this next point? Oh, LLMs and diffusion models are driving real world breakthroughs. So I think they're going to talk about this more later. I'm not exactly sure what specific uh, um,
Yeah, yeah, I looked
things
into
they're talking
this. Yeah, molecular biology, there's when the drug companies try to build a drug or things like that, there's a couple of real big problems. One, is it going to work? The other one is, can we physically synthesize this? And then that is a very proprietary process, so they don't want to give that out, because if Novartis can do it and Burroughs
about.
Wellcome can't, or something like that, right? So it becomes that way. So yeah, they are definitely looking. I know Novartis is spending quite a bit of money on this area already.
And there are labs all around the world and lots of groups that have come together to specifically, I mean, it's a huge range of problems.
Right.
And I'm surprised actually that, and I'm impressed that much of the latest diffusion modeling work around the probabilistic theory application is coming from labs which are driving molecular biology and drug discovery work.
Well,
So,
you know what it is? There's just a ton of money.
yeah.
Yeah, let's just be really honest. There's a ton of money in that business. If you just look at who's the guys that make what's the new weight loss drug that is really a diabetes drug?
Yeah.
They're projecting what, 4 or 5 billion a year from that one product. And
Munjara?
yeah, thank you. Yes, thank you, Walter. Yeah, 4 or 5 billion a year for that one product on the off-label, literally, because the weight loss is the off-label use of that drug. It is, primarily a diabetes drug, but people are paying thousands a month essentially to use this drug. So it's a numbers game. It's a pure money game.
Yeah, that's why there's a lot of money to invest in startups there. Shulin, you had your hand raised?
Yeah, I was wondering for the medicine part. So like sometimes the best output cannot be synthesized. So have they tried kind of like building two networks? So one for synthesize and one for kind of like predicting structure, and one for trying to detect if it is synthesized, if it can be synthesized, or they just combine everything in one neural network, kind of like a neural network that's trying to produce something that's both high performing and also be able to be synthesized.
I don't know how they do that, but having worked for these companies, I would guess they'd probably see what they can come up with logically, if you will, and then see if they can synthesize it. Because there's a whole bunch of things that can go wrong in synthesis that work really well in a computer. So
Yeah,
you want to narrow it down to before you start really expending the money in trying to synthesize.
off the top of my head, it doesn't seem intuitive that there's a lot of overlap between the two problems, that by solving them together, you make the models better.
Yeah.
Right.
I feel like that's a process that they probably take different data. Like for like predicting the model, they may try to kind of like take the functional groups, like what atoms should be in what places, to see kind of like what kind of like thing to give it the best performance. But for synthesize, you may actually need to consider the chemical process that like yeah, kind of like the first data set would maybe on the what kind of structure have what kind of performance, and the second structure would be for synthesized part, you may kind of like have each process gives out what outcome. So
Yeah.
that's what I feel like they probably should train on different data sets.
Yeah.
Yeah, there's like 100 slides in this deck, so hopefully there'll be a little bit more commentary, Shulin, and maybe there'll be an answer to your question. I have not thoroughly gone through all the slides yet.
Okay.
All right, the next point, I don't think anyone's going to be surprised. Compute is the new oil. So even if you're a small startup and you're working with a 7 billion model, you still need a lot of GPU compute. So the people making the chips are making a lot of money. Gen AI saves the VC world.
Hey, does anybody know, Ted? I'm sorry to interrupt. NVIDIA is a no-brainer, right? but Intel and AMD are building other chips too to
Yeah.
help with the process.
Yeah, so not only they are building, so it's a whole new ecosystem is coming up. Uh, Intel's main focus has been a little bit on the one API or some way of open model, because CUDA model is kind of innovative for
Kinda. It's there's a
so
hard wall there, Dave.
Intel definitely is farthest behind in this race amongst these three players that you mentioned. AMD is somewhere in the middle, and I've lately seen almost every reasonably markets capture size product, right? Addressing AMD's GPUs as well. In the recent earnings 2 or 3 days ago, AMD stock popped up 10% because they expect the AI related sales to go up. That's on the training ecosystem. There is another training ecosystem, GraphCore and uh, Samanova and Cerebras. Amongst these companies have built custom hardware. Oh, and then TPUs, by the way. So Google also has TPUs in the first list. The only catch with Google is they do not sell this in the market. It's just in their cloud versus these other three players sell in the open market. Then there is this other set of players where they build this large scale custom products, Cerebras and GraphCode, focused only on machine learning training and inferencing. The third category is just the inference accelerators, or sometimes even offloading. So there are a lot of companies, including AMD and others, which are building FPGA-based accelerators or non-FPGA-based ASICs, which coexist with the CPU and GPU and kind of come as a separate subsystem for your machine learning, where not everything is running on the GPU, but something on the slower system as well. But it's an accelerator for your entire system rather than paying a lot of money. And then there is fourth kind of chipset ecosystem all around just the inferencing chips. So of course, TPUs, for example, have the edge thing. So that's the fourth one. And then in parallel, there's two systems, specific system focused on CPU, GPU coexistence, or just CPU. So there is two specific companies called Neural Magic and Colossal AI. Especially Neural Magic, it's started by one of the Gödel Prize winners, Neil Shavit. And they focus on, and there's another one called Third AI. So it's supposed to be Third Eye, but yeah. So these three companies specifically have solutions for accelerated models to run on CPUs. And there is Apple is coming up with its own ecosystem where they have the shared memory and the neural engines sitting together in the system. So this is, and of course, all the recent models are now available on PyTorch, on TensorFlow, or on what do they call it? Apple Silicon M something, right?
M1, M2,
M1.
the M3. They just shipped
That's the
M3.
series. But what I meant was, the configuration.
Oh, it's Apple Silicon is kind of the big banner name on top of it.
Yeah, but specifically for your models, you have to specify what hardware infrastructure you are training or executing on, inferencing on. Anyhow, so I mean, this is, and then by the way, sorry, this is on the hardware side, and on the software side, you have what has accelerated this whole explosion is three specific things. One is the PyTorch Open Consortium. So previously, PyTorch was all Meta. And around 2 years ago, they said, well, let's have a consortium. And it's not just Facebook anymore. It's actually owned and supported by this consortium where AMD and others are part of it as well. So all of them are together making sure that when the new version, especially like the 2.0 version came out, that catered not just to the CUDA hardware, if you may, but worked on all hardware. How it made it work was through the software layers, leveraging the compiler technology called LLVM, which has 20 plus years old, but it has proliferated with every single hardware or sublayers where you can basically divide your problems into smaller subproblems and focus only on that. And with that, the hardware to actual PyTorch interpretation layer, there is a huge set of LLVMs which can be written all independently, and all you need to write is the lowest layer of the hardware-specific LLVM for your acceleration. And OpenAI is one of the big contributors to that, specifically from their layer called Triton, Triton. For last 2-3 years, they have been out. And one way to look at how this works is if you look at Flash Attention 1 and Flash Attention 2, or any of some of these recent hardware-specific engineering acceleration, including deep speed work from Microsoft, they are writing kernels in Triton so that it can run across multiple subsystems. So all of these innovations are coming together to make it feasible. It was a very long answer, sorry, or a summary of what I think.
Can I ask a quick question? So if I think of NVIDIA kind of was in the right place with a product that did matrix multiplication, right, very efficiently. And then AI started to be kind of framed in this context of matrix multiplies. So of the companies, especially maybe the big ones that we're talking about, are those new products all still in that same space of let's do matrix multiplies efficiently and quickly? Or are there any other rethinking of the architecture? Things like sparse matrix and stuff like that.
Right, very good question. So the recent engineering work is related to helping accelerate your, if nothing, to like Flash Attention and Flash Attention 2, or sparse attention, or any of those approaches. When the initial attention network was released, the bottleneck was not in the memory subsystem. So, it was still on the compute subsystem, right? So NVIDIA was the king there with all the, as you said, matrix multiplication to generate this whole attention scores, if you may. That's where majority of the time was spent in your transformers models. However, over time, people realize that you don't really need to recompute everything every time all over again, whether inferencing or not. So engineering came into the picture, including KV caches, and then recently Flash Attention 1 and 2. So what that did was, before Flash Attention came into picture, even though people were doing all these attention optimizations, it was really not helping with, they were improving the flops that were being spent, but with all this KV cache and other enhancements that happen, and the model size and the data size that they had to deal with, especially with the bigger dimensions, the bottleneck was not on the compute, it was in the memory bandwidth. So now much of the work that is going on recently is in improving, because you cannot, there's a improvement in compute has been 10 times versus compute improvement in memory has been 2 times, or the gap is increasing between how your memory access to the amount of data that you need is improving versus the compute that is there. So
I'd add 2 things to that if I could, Dev. So one, FPGAs always lurk in the background. And I've been trying to follow FPGAs as closely as possible as these diffusion and the best place to find out if they have any sort of answer is you look at the blogs from the solutions engineers, like the field engineers from the FPGA manufacturers, and they are shit so far. That'd be the like really brief summary. They're like trying to convolute their way into describing how one might use an FPGA to recreate some part of a bottleneck of some part of a model. And I have yet to see anyone show kind of a totality end to end. Here is a way in this new world to use FPGAs. We were almost there with convolutional neural networks and things like that, but we still weren't there. Like in the LSTM world, we were almost there. And so FPGAs are always like almost there. It's kind of the state that they are usually in, and that's the state that they continue to be in as far as I can tell. And unless anybody's seen something different, I have yet to see anything that's like, oh, that makes sense. It's faster, it's cheaper, and it's better. I've not seen anything like that.
Do you know, does anybody
There
know if
are
they've done anything with segmenting the problems to run in multiple data centers at the same time?
So
White
that was going
training?
to be the second area is segmentation, and that's both what Dev was just mentioning, memory compute segmentation,
Uh,
as well as like regional segmentation or
because I
partitioning.
because I
It's
know
performance
Amazon
based.
is spending a crap ton of money to improve their network throughput between their data centers. They are just spending, billions and billions and billions.
And so my comment there would be that I would, if we look at this as like a 20-year trend, the
Yeah.
thing that generally works is general purpose. A lot of times people will like kind of hone in and say like, here is this compute device that solves the memory pipeline, and it's this very complex compute device
Mhm.
for which there's demand in the hundreds of thousands of units, and it just peters out. It's so expensive because you're doing forge work on silicon, and forge work is if you read
Yeah,
about
the
kind of
most expensive thing you can do, right?
exactly
Yeah,
right.
yeah, right, yeah.
It's the thing that Intel just shut down their forge, right? Like here's this company, and they're like, this is too hard for us. We're not doing forge anymore,
Yeah, we're
right?
going to outsource it, right? Yeah.
And so that would be the one thing that I would say. Like there are a couple companies that have done something like that. There was in the early days of deep learning, there was a company in San Diego called they were acquired by, in fact, I think they were acquired by Intel, right?
Mobileye. Was that from there?
Mobileye is the
Nirvana.
recognition units.
It was Nirvana, Nervana. It was based in San Diego, and it was acquired into the Mobileye division. Mobileye's CEO is overseeing the Nirvana division of Intel now. But again, like Nirvana basically had solved this very small chunk of the workflow, and the general purpose machine that is NVIDIA kept winning. The one company that I think actually that's done something interesting, but using the exact same pipeline, is AMD. And AMD has specifically focused on non-consumer facing, so we don't see it. It's fully obscure. It is compute, and it's the abstract concept of deep learning compute in data center and in data center only, behind the wall of virtualization. So for the all intents and purposes, the users are not aware that they're using AMD compute when they're doing it. And the CEO has been speaking about this for like 3 years. It's generally the same approach as NVIDIA's, but it's just purpose built just for data centers.
Okay.
And I think both Amazon and Microsoft have special deals with AMD for their AI data chips.
It's what saved AMD this last 3 years.
Yeah. I know that the Amazon expansion though is massive, and there, I know some of the people. It seems to be my neighborhood is full of Amazon engineers all on the cloud side, and Amazon, big upper level managers, and their big thing is we have to have more bandwidth to solve all these problems between all our data centers, because we can't solve the problem in one data center. So we've got to be able to segment it and put a piece here, put a piece here, put a piece there, and then push it all back together somehow.
I
So to
think, Jerry,
answer,
that's solving a different problem though, because like we all know that loading something onto GPU is slow, right? You have a consumer GPU, you load a big model, it could take you like a minute or something ridiculous like that just to load however many gigabytes of model onto it, right? But the thing that I've seen more and more people talking about is the fact that even when you have data loaded onto your GPU, doing a matrix multiply is more than one order of magnitude faster than copying data from GPU memory to the register.
Mm-hmm.
So I don't know what exactly the ratio is, but let's just say for round numbers, it's 50. So you can do 50 matrix multiplies in the time it takes you just to copy your data from fast GPU memory to the register that makes it available to the matrix multiply. So then you can see that really, it's things like Dev mentioned, if you change the order that you do your compute graph, it changes the number of times you need to load the registers. And that's fundamentally the bottleneck, not really flops. So the old-fashioned notion of flops, I think, is not really where, right? And so then that's where I see NVIDIA doing more and more support for new data types. So going from flash attention changes the order of operations, which works well for existing. Flash attention doesn't require any special GPUs. It's just changing the order of operations.
Well, it tiles how much you get, and then it does a tile softmax. So that way, it doesn't have to. It tends to recompute rather than keep everything in.
But I'm saying you don't need a special chip. You can run flash attention on any existing GPU, right?
Yeah. It's
but so you see more.
Sorry, just one. It's interesting though that for every GPU there was specific kernel because of the memory limitation for each GPU. But anyway, go ahead.
Yeah. So we've had mixed precision, meaning 16-bit float for a while. Okay. But now you see, well, B float is being used more in training of models, and now we're going to 8-bit training and 4-bit training. So I think that's probably what these companies are working at in the background.
I mean, that's what the TPU is, right? Is it's flops on ints without getting rid of all of the distracting the floating point. I mean, floating point math is hard. If you've ever done a binary logic or digital logic class to do float, they're a bugger, right? I mean,
but that's what people are seeing is the wrong solution, because even with full precision 32-bit floating point, you can do like 20 matrix multiplies in the time it takes you to load one register. So instead, if you can switch it from a 16,
right?
What's that?
That's what CUDA NN has been for the last 8 years.
Right. So if you can switch from a 16-bit to an 8-bit data type, you can load the data twice as fast. And if you can switch to a 4-bit data type, you can load the data 4 times as fast, let alone whatever happens with the actual compute, because matrix multiply, it probably is faster for like int 8 or whatever, right? But so
I don't think
anyway, that's
there
one
hasn't been shown to be
a
I think the question was around hardware. I don't think there's been shown to be a hardware solution that helps with the reordering or increase registers or register pipeline.
It's not the hardware solution, it's a software solution.
Is that what is type problem?
Compiler optimization. But to answer original Roger's question, so I think some of the innovations will automatically come, but right now the biggest focus, there's this whole industry segmented into small pieces. So there is specific hardware being created. There's a company called Grok, which has been around for 7 years, GROQ, and they're building LLM specific inference processors. Right. Okay. So
what's the claim to fame with that?
I think they
Speed
have
in
HPC and labs that is being used, and they have I think a talk coming up in the I'll look at it. Some labs, national lab is using it for. Of course, they didn't disclose the exact use case there, but again, a lot of isolated little stuff, just like proliferation happening everywhere right now, just like .com boom time. Some in hardware, some in the network processors, and so on and so forth. But it will eventually settle down somewhere, I guess.
So one of my old research employees from USC said at Brock he had to implement a transformer in basically not machine code, but
assembly.
Why did I forget that? Yeah, assembly.
Yeah, we all tried to put that out of our minds, Patrick. Those of us have done it, So that's where I started in this, writing assembler.
So one question I had then is, so are all these approaches GPU? Is it SIMD, single instruction, multiple data? Are all the approaches going down that same path?
Yeah. Eventually, essentially, that's what you end up doing. You have a model. You want to improve inferencing across multiple users, for example, right? Or you want to the way you count your tokens per second is either catering to one user, or are you able to do it cater to multiple users? In which case, you maybe that's not answering your question specifically,
Yeah.
but
So my
I mean,
my
that's the
question was
concept of a
more.
flop, right? That's the difference between a flop and a hertz, right? Essentially, is the flop is the flip over of the entire matrix.
Right.
And my argument to summarize what I was saying is that a lot of people have tried to create more specialized hardware, FPGA being one side and then specialized memory pipeline being the other, but they tend to die. It's so hard to economically support creating a specialized hardware that ties to an architecture. Now, we have yet to have an architecture such as LLMs that is so good at real world problems. So that may have just changed, right? So that the economies that have made that impossible in the last 25 years have just shifted. And so maybe making an LLM specific piece of hardware for the first time in 30 years actually is an economic viability.
Yeah.
So Roger, I'm not a hardware guy, but my high level thinking is that if you have two matrices that are 2048 by 2048, and you need to multiply them together, if your whatever core is only doing like 16 by 16 matrix multiply or whatever, there's a lot of SIMD that you can do with all those tiles of your 2048 matrices. Does that make sense?
Well, yeah, no, absolutely, and I agree. When you're doing dense matrix multiply in large language models, my impression is that sparsity is a big issue. That there's a lot of this stuff that's a lot of the matrices are zeros. So I've been wondering. In the old days, way back then, they had something called a transputer, which was kind of compute and memory, a small chunk of that, and with good communication paths between the transputers, so that you could have general purpose in the sense that they each ran a general purpose program, but they weren't all locked into the same instruction at the same time. So you could have more flexibility in the types of algorithms you'd implement, like a sparse multiply. But I haven't heard anything like that happening in this round.
Yeah, but at the end of the day, matrix multiplication is the core of it. Howsoever, it can be accelerated, right? Whether through tiling processes or some specific hardware, the neural engines that they have on, in Pixel and Apple iPhone and wherever. I've seen recently, like in last month, papers published on enhancements to, they call it GEMM, right? Matrix multiplication, whatever, CUDA GEMM is CU GEMM. So something specific to CPU came out. So people are trying to figure out how they can bring that core operation in different ways and on different hardware and accelerate it at the end of the day. And then it's still SIMD. End of story. Right now, it is still SIMD.
Yeah.
All right.
Okay,
so
thanks.
if we're good, I'm gonna move on to the next bullet. Okay. So generative AI saves the VC world is this guy's quote. So $18 billion from VCs into generative AI. I'm curious what you guys are hearing. I know two people whose companies who are not doing AI, who are not doing generative AI, whose companies lost funding recently. And it seems to me that not only is 18 billion going into generative AI, but it's also people are so excited about some of these things that it seems to me they're becoming less interested in other ideas. Are you guys sort of seeing that?
Well, Sully, maybe you can comment on that since you work more in the VC world than.
Yeah, I mean, it's a function of the VC economics, the way VC math works, right? Which is, I need to, historically through analysis of data, I need to make 10 investments, one of which returns 1,000x, and the other 9 I don't give a shit about. And so I'm actually intentionally investing into volatility. That is the nature of the VC thesis. And so disruptive technology creates volatility.
Yep.
And you don't know who's going to win. You don't know why they're going to win. Each VC has their own like reasons that they invest this way or this way, or I've got this, magic 8 ball that tells me this. But at the end of the day, from a category of investment, which is truly much more private equity and traditional finance than I thought as a youngin'. I thought VCs were tech people and that they understood technology and they were doing X or doing Y, doing Z. They don't know any of that, right? They're following the ball, and the ball is technology volatility. And so with LLMs, unlike other stuff that had promise, LLMs have guaranteed that they're going to disrupt technical processes. Do we know which markets are going to respond to that, right? Like cruise, great example. Cruise, I was in Austin last week, or a week and a half ago. Holy shit, I have never been almost hit by an autonomous car so many times in my life. And oh my God, it was crazy. And they were like, they're these huge intersections and they're just wedged, right? So you get like 4 cruise taxis and they all run into each other and they don't hit each other, but they come like their safety thing goes off and they all stop. That is a VC investment because it's like, it's just so, again, it's so disruptive. But like a lot of things, as it becomes more clear what the shape of that disruption is going to be, and you're not going to hit the 10-to-1 ratio of winners or the 1,000-to-1 ratio you need on return, that's what takes it out of favor. It doesn't mean that it's not a good technology. It doesn't mean it's not going to disrupt industries. What it means is it specifically does not match those 2 very specific ratios that you have to hit, a 1 in 10 hit rate with a 1,000-to-1 return.
Got it. Makes perfect sense when you have this sort of money that they're moving around.
Yeah, if you had $100 million to spend,
yeah, where are you going to put it, right? Yeah, or you had
if you'd like to borrow 100 million, we can talk after.
Yeah, if you had $1 billion and you wanted to put it in 10 bucket bets, where would you make the bets, right? So,
all right. So the next point here is the safety debate has come into the mainstream.
yep.
If you guys are okay, I'd like to not try and have conversation because we could just use up all of our remaining time. I think that though, if we continue with this and we go through the slides, there will be a time to talk about it.
I would love to do that as a topic, like a dedicated day.
Yeah,
I think that would be an interesting one.
It's obvious that, right, the EU has, legislation they're looking at. We just had an executive order from our president.
Right.
So right, wrong, good, bad, they're
and billions of dollars just flowed.
Yeah. whether they're actually doing anything for safety or they're helping the big companies, helping the small companies, it's definitely in the mainstream, right? We can all agree on that. What is this? Challenges mount in evaluating state-of-the-art models. As standard LLMs often struggle with robustness. Considering the stakes as vibes-based approach isn't good enough.
That's the question that Roger had asked earlier, right? How do you specify the quality and measure it, I guess? Kind of related to that, if I'm not mistaken.
I'm wondering
and even just like general, when you build a new model, right? You're like, let me run it on this big bench and it's like 75 different tasks. Is that really that accurate? I don't think anybody really knows.
Yeah. The other thing is, are we talking, foundation models here?
I think so.
Yeah. So if you think about the foundation models, right? Everybody else builds on top of the foundation models, hence the term foundation model. So, if you build on a crappy foundation, you're kind of screwed, if you will. So I think maybe that's what they're referring to. But if you've got more detail, Ted, maybe we should just move right along into your slides.
But I think the idea is that, let's say you and I both build 7 billion parameter models, okay? Can we categorically say your model is better than mine? It's like, well, you did 1 point better on this benchmark, but I did only 0.2 better on that benchmark.
That's why I was wondering if it was more the foundation models, because the foundation models, you're doing...
Right.
There's more of a differentiator, if you will, there, perhaps, than than if you and I start from the same place and then customize out,
Yeah.
So,
Yeah. So what I would say is that if you're just going, like, say, to Hugging Face, and you're looking at different models, whatever,
exactly.
you should definitely comparison shop, because if the task you have has more like mathematical reasoning involved, then you may find that this one that had the highest rating overall is not necessarily the strongest at mathematical reasoning. And so
Correct.
if, like, for whatever reason, like your LLM is going to do some simple math and, like, say, oh, you want 4 tickets in this section at $100 and you want 2 tickets in that section at 75, and it has to add, like, that might be a place where you don't necessarily want the one that has the highest overall benchmark or whatever.
Right. Makes sense.
All right. So the rest of this, they've divided it into these sections: research, industry, politics, safety, predictions.
Ted,
So if we
by
just
the way,
go in
where did
order,
this
the
come
first
from?
like 20 slides or whatever.
Where did this come from? Do you have?
It's this guy Nathan who works at Air Street Capital.
Oh, okay.
And I apologize. I got a warning. I don't know if my internet's slow. I don't know if my audio's dropping.
Yeah, your picture is freezing when you're talking.
Dave, do you know anything about this guy? I just know he's been doing it for at least a few years.
That's all I know. And I think it's a VC firm, right? That's where he works. He's probably one of the analysts. I don't know what he's.
Yeah.
Yeah.
I don't know these guys.
He's British.
All right. So, oh my goodness. All right, I'm not gonna. I think that's mostly stuff that was on the webpage. If you guys want, we can take a look at. They have sort of like the top 10 predictions that they made for the next 12 months last year, and we can look and see how they did. You guys want to go through those?
Sure.
Okay.
How do you full screen?
So,
slideshow.
The first prediction was a 10 billion parameter multimodal reinforcement learning model is trained by
Hey, Ted, can I interrupt you?
I think Ted froze.
Yeah, I think my connection might be slow. I apologize. Go ahead, Dave.
No.
I just wanted to ask you if you are able to press slideshow so that we can see a little bigger because the font is really small. Are you running some model?
Right. Are you guys seeing that?
No, we're oh there now we are. Okay.
Yeah. Thank you.
All right. Sorry, I think my connection is slow today. I don't know why.
I'll turn off my video. Maybe others can do too.
Yeah.
I guess I could turn off my video too. So the first prediction was a 10 billion parameter multimodal reinforcement learning model is trained by DeepMind, 10 times larger than Gato. So what ended up happening is the trend for bigger and bigger stopped. So we didn't get something 10 times bigger than Gato. NVIDIA announces a strategic relationship with a AGI-focused organization. So they gave themselves a middling grade. I don't know. I don't know how you define a general an AGI company.
So I think this company called Inflection AI, they have a product called Pi. Their co-founder, Mustafa Suleiman, he was co-founder of DeepMind as well. So he has been in the news all over right now with AGI claims and his next Turing test and so on and so forth. And that discussion aside, NVIDIA has invested, like they received 1.3 billion investment as their Series A funding. So NVIDIA is, I think, one of the major investors. So Cohere has, of course, the language model that I don't know what it is called and how they serve it, but I know they have a cloud service for language tasks, and they have a language model. So oftentimes I've seen Cohere's ELO rating as well compared to Cloud, Bard, and GPT, of course. So in that sense, it's like more of an ecosystem that they're building rather than, which is what they're saying, announced is not a strategic relationship, but kind of a yellowish investments. Yeah, and Adapt is also in the similar realm. Let me not go into that detail, but yeah, automating tasks.
Okay.
And all.
See here, prediction number 3, state-of-the-art language model trained on 10 times more data points than Chinchilla. I think we've definitely seen people are focusing on quality and quantity of data. So the early bigger models had more data, and so they were better, but people didn't necessarily disentangle how much was better because of the parameters and how much was better because of the data. So now I think people are focusing a lot on the data. Generative audio tools emerged that attract over 100,000 developers. So it says 11 labs and Resemble AI. I'm not familiar with either of those.
Yeah, 11 Labs.
Anybody heard of these two companies?
Yeah,
No.
I know about 11 Labs. I think they do audio and audio related stuff, I think, if I'm not mistaken. And I thought I'll use their API, but it just felt it was expensive, so I didn't use it. But seems like they have a very big ecosystem.
Okay.
And you're right. It's like one of those companies we had not heard of, but they're doing pretty good.
Yeah, apparently. All right, prediction number 5. One of the haves, they call them GAFAM, invests over $1 billion. And yeah, since Microsoft invested 10 billion, we've seen Amazon put in and everybody. So lots and lots of investment. Definitely a yes on that prediction.
They kind of undershot that mark.
Right.
It was huge undershot.
Yeah, exactly.
And
yes,
to
with
that
5
effect,
exclamation points.
Yeah, Microsoft stock after recent earnings went up significantly after they announced Microsoft 365 Copilot, and they're claiming that they will have a bump of 10 billion in revenues per year just because of in revenues.
Wow.
Market cap is of course going to just keep on growing. And
Oh,
so here's an interesting one. Yeah, go ahead.
They were up like $6 a share, I think, in the last day or so.
Yeah. Here's an interesting one. They predicted that semiconductor startups will get bitten in the face of NVIDIA's dominance. So they're predicting that a high-profile startup will be shut down or acquired for less than half of its most recent valuation. And so they say, no, there's been markdowns, but nobody has gotten wiped out this year yet.
Yeah. And my take is that it will have to be software driven rather than hardware driven, just like how Linux killed Solaris. So, something innovative that side will shift it. And that's the effort with Triton, and I don't know how to pronounce it, but, all the other layers of LLVM and compiler technologies.
Well, it's Chris Latner survives again.
Yeah.
Yeah.
See here, a proposal to regulate AGI labs like biosafety labs gets backing from an elective UK, US, or EU politician. And they say there's been calls for regulation, but no explicit backing.
They may have just been a little bit early on that one.
I don't know. I'm not familiar with this BSL.
Yeah, I don't know. Well, so this is, you can't go out and build like these microbes that can wipe everybody off the face of the earth type thing, or you shouldn't. You know what I mean? But, they do, but whatever. That's the concern, that level of concern. And, when you get all these EU, US politicians and things like that, they only deal in, doomsday scenarios, if you will. And here it was, we're all going to get wiped out by, AI or something. Nobody's going to have jobs, whatever gets people to the polls, I guess.
Let's see here. Second to last, over $100 million invested in a AI organization that's alignment focused. So they counted Anthropic in that category and said, yeah, that counts. They got $4 billion.
What's an alignment organization?
alignment meaning aligned with your goals, safety and
I see what you're saying.
toxicity and
Yeah. So somebody will come out with some sort of big mission statement and align with that then, I guess, of those
right. So
goals.
for example, GPT-4, people are measuring, right? How does it do on translation and can it summarize? But they aren't actually trying to measure, well, the main benchmarks aren't measuring it on, is it potentially biased? Is it potentially repeating toxic things? Is it whatever?
Yes.
Those aren't in our standard benchmarks. Whereas somebody like Anthropic is much more focused on those issues.
Okay.
And then the last prediction,
Well,
Baser,
actually, OpenAI recently launched some I don't know how to say it, but they're calling people to test their models and give potential scenarios when the models are free to the people and they use it for bad purpose. And they are putting a lot of money into regulation of their models and future AI models.
yeah, I'm a bit skeptical. I feel like they're doing enough to try to create publicity to say they care, but they don't really care.
Yeah, so this may be kind of, you know how like a paper company will say, we really care about the environment type thing or something like that. So
right, but their job is chopping down trees to make paper.
Yeah, and using toxic chemicals to convert the wood pulp to, blah, blah, blah.
Right, so they may say like, oh yeah, we sponsor lots of research in like green chemicals to make paper, but it doesn't mean they're going to stop doing what they do.
Yeah.
And
anyway,
Jerry,
people are free to disagree.
And just to answer Jerry's question about AI alignment, the specific definition that Bing GPT gave, which is what I thought it means mostly, but I mean, I know the parameters and metrics is what Ted was saying, but I think at the end of the day, they say AI alignment is the process of ensuring that AI systems operate in a way that aligns with what humans consider desirable behavior.
Well, that leaves a lot for interpretation.
Yeah.
So but that generally it's right. Is it helpful? Is it toxic? Is it that kind of stuff?
Yeah.
All right, and then the last prediction, a major user-generated content site such as Reddit negotiates a commercial settlement with a startup producing AI models for training on their corpus of use. Oh, I see.
Oh, yeah.
So
Okay.
yes, OpenAI secured a 6-year license to get Shutterstock's data so that they could freely train on it and not get sued.
Yeah. And right, Twitter is suing Microsoft for using Twitter data and their models and whatnot. So
yeah,
probably. And the biggest name, sorry, Jerry, the biggest name in this Stack Overflow and Stack Exchange and check. All those three stocks plummeted after GPT-4 came out because it's their data that is being used to answer many of the questions, right?
Yeah.
Especially related to what I do.
All right, we got a couple more minutes. I'm just gonna see if we can't dip our toe a little bit. All right, so this is kind of rehashing the first bullet point we had, that GPT-4 is kind of crushing the competition. I don't know if you guys want to scan over the slide and see if there's anything further to discuss. You've all heard, right? Did well on things like SAT, bar exam, MCATs, blah, blah, blah.
Yeah, the only thing that I've mentioned this before. I don't know where. Oh, yeah, there it is. The slide. The only thing that concerns me is that yes, it passed all those exams and whatever the measure is. When my kids use Khanmigo, which is based on GPT-4, and they had been working on that product for 6 months before GPT, like when GPT-4 was announced in March, they co-released Khanmigo in beta mode, and now it's more publicly available. But I'm always worried that it may give a wrong answer, and it does give wrong answers sometimes. So, and this is like my younger one is in 4th grade, and older one is a sophomore. So while I encourage them to look at that, but don't trust everything that it says. And it's a little scary though.
That's an interesting question. For teachers and things like that, I mean, where do all these things fit in, you know?
Yeah, there's a specific benchmark for K to 8 middle schoolers, up to middle school math. And again, you know, the claim is that it's all, I don't remember the numbers, the benchmark numbers, but people do keep coming out. Remember that MIT paper? So people keep coming out with, well, it did solve it, and then people find holes. Well, no, it didn't. These were all the holes. Yeah. And that paper was retracted. So yes, it may be better than other models as the green bars show, but have to take it with a grain of salt. Is it that?
Stupid question. Have there been any like court cases or something like that of people trying to, you know, use plagiarized stuff to put out like news stories and things like that? Like, you know, I guess Fox News isn't the high bar to clear, but you know, have there been? I mean, I haven't heard, but maybe I wasn't in tune with that sort of stuff.
No, I've heard, and I should, you know, sometimes I read about stories where AI is being used for plagiarize is one, but what's the propaganda is another one, right? False, fake news or propaganda, but crime is the third one. So
the main thing that I've seen is just people got in trouble because what they produced was factually wrong. So if you have a CNET article and it's just got facts wrong in it, then you get crushed for not having proofread what GPT, you know, gave you.
And what Fox News proofreads anything they put out?
Let's
I'm
not
not
go
saying
there.
they don't have lies, but I'm saying they know that they're saying what they mean to say. But like all these different magazines and newspapers and that lawyer, you know, where they got in trouble was because their content was factually inaccurate.
Yeah, and there is this recent one from this week. That's the one that I was thinking about. Guardian is asking Microsoft for damages. So there was a recent article about some death, and an AI question popped up. What do you think? Was it a murder or a suicide or something like that? And Guardian got a big, you know, backlash for that AI generated question. And
you mean the Guardian newspaper?
That's a Guardian newspaper, yes, UK newspaper.
UK newspaper,
yeah. So yeah, it is scary. And the case that Ted talked about, where a lawyer submitted an argument or whatever it was, and then there were references of 6 prior cases. Apparently, those didn't exist. GPT-4 was hallucinating, and the lawyer did not do due diligence. Having said that, I mean, I have used to help someone get their traffic ticket waived rather than hiring a lawyer. Well, just give me your points and we'll compose an answer. And here are 3 answers. Let's see which one you like, and we can send that.
Did you fact check it?
Yes, we read through that.
Okay. Well, good for you.
Well, wasn't the Onion sued out of existence by, you know, major banks for publishing, you know, stories, which in the end were correct, but it's just that they're politically favorable and they just got crushed, right?
Well, this is an interesting one. RLHF, right? Because there's so many people now saying, well, maybe RLHF isn't the be all end all. But for last year, I guess it was last year's, it was a bell of the ball. But
yeah, I feel like there's some questions being asked. Definitely RLHF became mainstream. And I would say people still find that it works well for things like alignment. So like for tone, I don't know that it works as well if you're trying to like load your medical data into it or something like that, you know?
Well, the big problem is the HF, right? The humans, where you get a bunch of doctors to, in your case, that example, to go in there and, tweak it. Well, I don't think
I mean, you have to train the reward model. So that's the expensive part. I don't know if you've seen, there's papers where people try to automate training a reward model. So using like a smaller model to help train the reward model. But yeah, I agree with you. I think it's not necessarily like, wow, this is the greatest thing since sliced bread. It's like, yeah, it definitely works. OpenAI got it to work well with GPT, but not everybody's using it.
Yeah. Well, I think, there are issues too in scalability when you start putting humans into any system, assembly line fashion. So
yeah. And I don't know if you're familiar, but not all people agree whether like this generated text is better than that, and that's why you have to have the reward model pipeline the way it is. You can't just score an answer. This is a 7, that's a 9. Because people
So you have to relative ranking, right? So yeah.
So
just did
and
this
if you're
in my
familiar
course,
with like chess or like tennis rankings, you can have somebody who's number 3 in the world that on a bad day lost to somebody who's 30th in the world, and that doesn't mean that they should be 31st in the world just because they lost that one time.
Yeah, what is that called? That is the ranking.
ELO.
ELO ranking, right? Because they use ELO for their label ranking or their response ranking, if you will. So yeah.
Yeah, I know OpenAI used ELO. I think you could do other ways, but that's sort of a general issue. What do you do when you have this oddball, like one person, really likes this answer and everybody else hates it?
Yeah, so it's wisdom of the crowd type thing or something like that.
Oh, so here's the next slide. Even so, researchers are hoping to find an alternative because of what you said, Jerry. It's expensive to have humans do the rating.
Yeah. And there are, there's what RL, what's the other one? RL shit.
I've heard people come up with different things. No, I don't think anything's become mainstream. I've seen RLAIF, so have an AI model do the feedback.
Yes. That's the one I've been playing with in my spare time. And it's interesting, but I think we still got a ways to go on that.
Yeah, there was this paper called Lima that you see in the middle that came out. Does anyone have more knowledge about that?
No, but
second bullet there.
Yeah, I see it.
I have not read that.
Yeah,
might be interesting. Might be an interesting paper for us to do.
Yeah.
Oh yeah, maybe if we keep going through this, we'll get some ideas for future topics. I just noticed, so we're actually at the top of the hour.
Oh, okay. Ted, can you put a link to this, or is it somewhere in the thing, or is that it? Oh, okay. Yeah, RLAIF, very at the bottom of your screen, man.
So I think it's at my end, not yours, but the audio broke up, Jerry. Couldn't quite tell, but I just pasted the link for this report, if that's what you wanted.
Yes, it was. And I was also noticing at the very bottom of your screen, there's the RLAIF reference to their paper. So
there it is.
Yes.